Hi, everyone. Thank you for joining us today to talk about the new product, the United States Large-Scale Solar Photovoltaic Database, the USPVDB. Just a little bit of housekeeping. Everybody is muted. You probably noticed that as you came in, and that was intentional. We do want to hear from you, though. So please go ahead and search for the Q&A window. That's where you can enter questions and comments and whatever. We will be monitoring that through the presentation and then allow that to be what we answer when we get to questions and answers later in the presentation. Also, you should know that this webinar is being recorded, and we will share that recording with you after the webinar, as well as the slides. So don't feel like you have to screen grab anything. We'll hand it over in due time. As well, some quick thanks. We'd like to thank the U.S. Department of Energy's Solar Energy Technologies Office and the U.S. Geological Survey under the National Land Imaging and Land Change Science and Energy Research Programs for funding this work. We surely couldn't have done it without their support. And finally, I'd like to thank the National Renewable Energy Labs, Jordan Macknick and Gail Mosey. They provided key data to this data set and are continuing to be collaborators on this project with us. Finally, I'll just note it's very exciting. We are closing in on 100,000 hits on this site, and so we're just really excited to be able to share information about it with you. Next slide. I'm not yet seeing that slide yet. Okay, here we go. So this is the team. It's been a fabulous effort working with everybody here. You're going to hear from really the superstars on the team today: Sydney Fujita, Zach Ancona, and Chris Garrity as we move through the presentation. Next slide, please. So I'm going to cover a little bit of project background, hand it over to Sydney to do some data overview, then Zach to do the database development stages, and then Chris will take it over to give you the demo for the website and the viewer. And then we'll have questions for Q&A. So how did we get started on this effort? It's been a goal of ours to do this for quite a long time, and we've kind of been working our way closer to the full data set you have available to you now. This started back in 2019, working with Duke University to develop some deep learning modules to detect solar panels. At that point, we hand digitized a number of projects for truth data. Then a big effort was done by Mark Bollinger in his paper that was published last year looking at power density, and he collected those data in 2021. That was all the facilities greater than 5 megawatts installed through 2019, about 400 of those. Another tranche of data were collected as part of a property value analysis that Salma Almala put together across 6 states. In that case, we had 1,600 facilities. So we were climbing up to around 2,000 at that point. We released 4,000 polygons just recently. So that's what's in the data set right now. So that got us about halfway there. Next slide, please. These data were collected as part of a larger project called Community-Centered Solar Development, which is funded by the U.S. Solar Energy Technologies Office of the DOE. You can look into that project at that website, ccsd.lbl.gov. Actually, could I ask one of my co-presenters to just drop that into the chat for folks? This is a project, multifaceted project. I won't go into more detail about, but I do encourage you take a look at that project. It's very interesting, and we needed these high-resolution polygons to do a number of other tasks within that project. Next slide, please. And so thanks, Zach, we've been through a variety of steps here over the many years that we've been working on this. I mentioned sort of a number of pieces of data that came to us through other efforts, but as we started to think about this USPVDB in its full form that you're seeing today, it took a lot of additional steps. We had to create an inventory of the full set of existing data, georectify those pieces of data and then start the digitization of the full set, and then a lot of QC. All of this will be covered in the remaining part of this presentation. Finally, we built the data set viewer and website. All of this work has been tremendous and taken a lot of time. The good thing is it's behind us, and so adding more data to the data set now will be possible with a lot less effort, and we look forward to doing that in future releases of the data set. So I'm going to hand it over to Sydney at this point. And actually, just one quick thing, Norman just raised his hand. Please submit any questions you have for Q&A, and we'll try to answer them that way. And then also when we get to Q&A portion of the presentation, we'll take an opportunity to answer it then. Take it away, Sydney.
Okay, thanks. In the next several slides, I will provide an overview of the sources of data that we used when developing the USPVDB. If I can get the slides to advance. So our primary source of data was the Energy Information Administration's Form 860. We worked from a couple versions of this. The final releases in September of 2021 and 2022. So these covered facilities that were operational through the end of 2021. And this data was vital to the effort because it provides facility locations as well as a number of other attributes that we can use to identify and analyze the facilities. We were also able to use another data set that LBL develops. It's the utility scale solar data set that contains information about facilities that are over 5 megawatts. And this has already been georectified and had some of the attributes verified. So we were able to update some information about facilities using this. We also used EPA's repowering matrix, which allowed us to identify facilities that have been built on lands that or currently or previously suspected to be contaminated in some way or another. So these could be Superfund sites or previous mine lands or landfills. And this is something that we've made note of within our database. We also used the Inspire Agrivoltaics data, and this allowed us to identify facilities that, along with solar generation, also have some sort of agricultural services happening within the same land. So these have crops or grazing or pollinator habitat, and this is also something that we identify. And finally, we use Maxar Digital Globe as our primary source of high resolution imagery. And this is what allowed us to thoroughly investigate what these facilities look like and to digitize accurate polygons around them. I'm going to now walk through just an overview of the number of facilities that we started from and kind of how we downscaled to what we've released in this first version of the USPVDB. So we start with 4,460 facilities from the September 2022 release of EIA data. And again, these are facilities that were operational as of the end of 2021. And to get started on this, we needed to have a point location for the facility, a measure of capacity, and to be able to confirm that it is a solar generation site. And beyond that, there were a few screening criteria that we used. We wanted photovoltaic technology only for this data set. We focused on ground mounted rather than rooftop or a parking canopy. And we needed to ensure that facilities were 1 megawatt in capacity or greater. And finally, we had to be able to verify them through our digital imagery. So through meeting these criteria, we lost some facilities. A number were rooftop systems. We found some to be too small, and there were several that were of a different type of solar generation, and we've not included those at this point. And by the time we had established that we could not find up-to-date imagery for about 200 facilities. We end up with a final number of 3,699 facilities that are in the data set at the moment. Many of the facilities for which we didn't have imagery were kind of constructed and operational within the last several years, and we likely could find imagery of them in the future. It just hadn't been imaged recently enough. And I will now hand it over to Zach to fill you in on the details of the development stages.
Thanks, Sydney. First, with the data development stages, I can't not acknowledge some of the people like Dana Robson from LBNL, Mary Straka and Tandy Gutrow for really kind of spearheading a lot of the digitizing that went on here. Also with the people from Lawrence Berkeley National Lab, NREL, and Jordan Macknick's Inspire Group, and Gail Mosley with EPA. They're all just been instrumental for this part of the process, and we couldn't have done it without all those people. So the data development stages can really be broken up into four main stages, as shown in this slide. Basically, georectification, digitization, QA/QC, and then adding the attributes were really the main stages of this, along with the USPV data release and the creation of the web viewer from Chris Garrity and everyone. So these were all kind of incremental steps that we took to be able to make sure that these were taken care of. So next slide. So the original EIA points that we got, you can kind of see here, they're not always located on or near the facility that they're meant to describe. So the first step in this process, which was really spearheaded by Dana at LBNL, was really georectifying a lot of these points and trying to accurately place them on or very close to facilities so that we could go through and actually do the digitizing on these and be sure that we're putting the correct attributes on these, and that the EIA point was really located where we thought it was should be located. And we have a confidence indicator that reflects this. Next slide. So basically here, we used a confidence rating to show how EIA points were able to be kind of disentangling from one another. So in this slide, you see we have a kind of a four number confidence rating. So you have this low confidence. You can kind of see where we have multiple EIA points on a single facility with different arrays kind of all around that same facility. So there may be multiple EIA records with the same location that we had to kind of try to figure out which one they went to or which facility was which. And that came through a process of either looking at news articles or just attributes from the actual EIA to be able to accurately place these. On the right there, you can kind of see where we have a low or a medium confidence, where we just have a ton of facilities in the same place, but you don't really know which facilities belong to one another. Sometimes there's different phases that use different technologies, or they're just all so jammed up with one another that it's just difficult to be able to distinguish what belongs to which certain facility. So it's a process that we hope to kind of refine with future updates and kind of take some of these lower confidence facilities and upgrade them to our highest confidence. So, which will be the next slide, I think. So for this one, you can kind of see our medium or high confidence are ones where we had imagery, but maybe the whole facility hadn't been completed yet, or the imagery just wasn't quite up to date. So we couldn't necessarily get the most accurate boundaries on the entire array, but we felt that we were able to digitize enough of the facility to be able to put it into the database and have a good representation of what we think is the actual array boundaries. And then on the right, you can kind of see when we were pretty sure that we had the correct EIA location and we had good imagery, we were able to basically digitize a full polygon around these arrays and attribute it with high confidence so that people can be sure that, you know, when you're using this data, that these facilities are complete and they are, the full facility array that is in the actual EIA point data. So, so this graph really just shows just the level of confidence that we have in the database right now. You can kind of see on the far right of this one that our mean confidence rating is really very close to 4. Most of our facilities are that highest confidence rating of 4, but there are still some that are, farther back in the past or more recent facilities that we may not have imagery for, or just kind of those kind of convoluted facilities where we have multiple points on top of one another, or we just have those very busy areas with a ton of PV arrays that we need to get more input on to help disentangle. And that comes from a variety of ways, community interaction for people that actually know these facilities, or just more press releases that come out, better imagery, being able to kind of separate out the technologies between different arrays so we can assign the correct attributes to it. So that should be good there. So really during so the main part of this this kind of polygon creation was actually drawing the polygons, and a lot of that came down to these 4 key files. Obviously the georectified point locations that Dana from LBNL had provided. We worked with a working polygon shape file to be able to kind of work through this incrementally, and not, there's a lot of version control kind of stuff that we needed to be aware of here. We had a lot of people working on this. And then obviously using the imagery that we use was by way of the Digital Globe Image Connect plugin for ArcMap, which is a great tool for just having a really comprehensive list and archive of imagery dating back quite a ways, so that we could look back, 5, 10, 15 years to be able to search for imagery, to be able to actually get this type of digitizing done. And then the last thing was our progress tracking spreadsheet, which is again a form of version control so that we weren't stepping on each other's feet when digitizing these different states and different polygons, and just being able to track what was done, what needed to be done, what needed to be checked. It kind of allowed us a working copy of a lot of comments and a lot of ways to interact with each other, since we're all kind of from different agencies, and being able to kind of share that data with one another. So the primary imagery type that we used here for digitizing was the Maxar Technologies Digital Globe. It's a great tool if you have access to it, and it is, one of the better imagery sources that we were able to use for this. Obviously, when we couldn't find imagery using the Digital Globe Image Connect plugin, we used things like the Bing Maps aerial. In the Esri base maps, we used Google Earth. We used the NAPE ortho imagery, and then the USGS EDC SDDS, the data system for other ortho imagery. So we tried to pull in as much imagery as possible to this effort, to be able to make sure that we were capturing as many arrays as we possibly could with the data that we were provided from EIA. So, I mean, if you've ever used ArcMap, you kind of are probably familiar with how you edit polygons. We used ArcMap in this case and not ArcPro, because the Digital Globe Image Connect plugin currently only functions in ArcMap. So in the future, we may transition into ArcPro instead, as long as we can get the imagery kind of working inside of that program. But it's pretty, we basically just, created a big polygon to start at a very kind of coarse level. And then we went into kind of higher scales to be able to do things like editing vertices and getting these tight little corners in as close as we basically could. There were some rules that I'll talk about in the next slide that were used to be sure that we were all digitizing this the same way. And that, so this is basically the guidelines. So again, we had multiple people working on this at the same time to be able to not again, step on each other's feet with this. We used, we had about 16 members contributing to this, and we kind of went state by state. So each person would take a state, they digitize as many polygons as they could for that state, and then those would then be passed off to other people to be able to do the QC. Some of the key guidelines that we kind of used here were obviously only including panels and inverters. We tried to stick to about 5 or 10 meters in terms of the distance from the actual panel arrays to be able to just create an accurate portrayal of what the actual array looks like and not have too much extra stuff going on that kind of, may not actually be included in the facility or actually in the PV array. And then, as you can see in this slide here, some of these facilities are separate from one another. They're not always one big giant block of panels, and you basically need to create multi-part polygons to be able to assign a single attribute to different parts of a facility that may be separated by more than 30 meters. Basically, you can see kind of when we had some rules about how when a panel was too far from another one, we didn't want to include so much kind of dead space in between. We really wanted to keep it really tight to the arrays as much as we could for this first effort. So this is kind of just an example of one of our large facilities, with it's a multi-part facility. You can kind of see the gaps that we created. You can see when we didn't create gaps and we use kind of smaller slivers to be able to just really draw tight boundaries around these polygons. And this is just kind of one of the examples of, a very, this one was fairly complex, but at least it had, nice straight edges that didn't have a lot of stair stepping involved. There were more complex facilities than this, but we felt like that was a good one. A really big part of the digitizing process was disentangling these facilities. This is just an example that we have here about 2 separate facilities that were built at different times. The image on the left there is a Google Earth image poll, basically from a previous year. So some of the ways that we tried to disentangle facilities was either by looking at Google Earth imagery or digital globe imagery of different years to be able to see that that really, like the north facility that you see on the left was put in quite a ways before the larger facility that you see on the right. And that was one way of us disentangling these facilities. And another way was really looking at the technology used for each of these facilities that is included in the EIA data. That facility on the left is the panels are horizontal, so we kind of had some rules that we kind of figured out that when we see horizontal panels, you can kind of assume that a lot of those are kind of fixed tilt, what we call fixed tilt panels, where there's no tracking with the sun. They just stay at the same angle that they're at. The sun moves over them. They capture as much energy as possible. And then the new facility that came in on the right, you can kind of tell is vertically oriented. And that's another way to help disentangle, because in the EIA data, that would have been attributed as a single axis facility, or a single axis technology. So in that case, the actual panels move with the sun to be able to capture as much solar energy as possible. So these are just different ways that we use to be able to help disentangle some of these facilities when they were tightly bunched together like this. So like Ben said, QA/QC was a huge part of this. There were a ton of facilities that we were looking at, and they were all different. No facility was really the same as one another. There were some that were all kind of squares or whatever, but a lot of them were a lot different and needed kind of a second eye to be able to look at these. Every one of our polygons was checked by at least 2 people. So you can kind of see, like, maybe the first digitizer that went through may have digitized this polygon like you see in that image on the left. And then our final digitized polygon on the right, you can see maybe got, sucked in a little bit closer to the edges of the arrays. Some of the stair stepping on the left side of that facility, kind of you can see, kind of hugs a little tighter to the actual arrays there. So this is part of our QA/QC process, which was really just like making sure we were getting as accurate as we possibly could, as close to the arrays as we could. And then, we also had kind of some external reviews of the USPVDB, just the actual attribute table, which is, functionality of files, the consistency of data records, misspellings or other errors that we found, in this, in the EIA data, because, everything that's submitted to the EIA is, a voluntary, or it's mandatory, I believe, but it's user submitted, basically, developer submitted. So there are things that get submitted there that we kind of ended up cleaning up on our side just to make the database more usable and more queryable, and just more usable for the public. So, so a lot of the QA/QC was really important. Another part of this was, again, as Ben said, from Jordan Machnick's group with the Inspire group and Gail Mosley from EPA. We used a lot of other data sets to be able to add extra attributes to this database, to be able to identify certain types of site types, to be, to look at like areas that may have been formerly or presently contaminated, landfills, Superfund sites, mine lands, anything like that these PV arrays are really going on top of, so we can know kind of more about what kind of land change is associated with that. And the same thing with the Inspire agrivoltaic sites, where we know that solar facilities are really kind of pushing towards this multi-use aspect of solar facilities, which is, having ecosystem services associated with it, having crop pollination or crops, having pollinators be able to, be accessible for some of the vegetation that grows around it, grazing. There's a lot of things that kind of can be done near or around these PV facilities that can kind of have multiple benefits for a lot of different kind of aspects. So, and this, so part of this was basically, again, kind of going back to like how we took some of this data from Inspire and from the EPA repowering matrix, was really just, trying to use the EIA ID, which is a link back to that EIA Form 860 that has a bunch of extra attributes that we maybe didn't include in this. But that was a good link to be able to be sure we were attributing these correctly. And then also, just going off proximity using XY locations from the EPA's repowering matrix. So, looking at where an EPA point was placed, looking at the facility that we think it matched to, and then being able to verify that geospatially. So, and then, again, these facility attributes, we pulled plenty of these directly from EIA. And then we also modified quite a few of them, things like lat long, where, the original EIA lat long may have been of the point, but we had moved the point and we wanted to reflect the actual facility location. Things like the facility type and agrivoltaic type, those are all things that we have added to the database that didn't come from EIA. And then, attributes like Z-score, which basically helps us determine, based on area and capacity, are we attributing this correctly? And that was kind of just an extra thing we added in to be kind of another check on our confidence attribute. So just being able to be sure that we were actually attributing these correctly and that we were providing the best data possible. The image on the right is just your basic PV array that maybe people aren't as familiar with what the tilt may represent, what azimuth may represent. This particular panel you can see is oriented east to west, so it's most likely this would be an example of a fixed tilt facility where there's no tracking associated with that actual panel. So just kind of a small little thing there to look at. And the last thing here was really this first iteration of this database, we really wanted to focus on a well-populated database that we were, pretty confident in terms of what we were putting out there, what the attributes we were putting out there, and the facilities that we included in this database. I do want to note that there are plans to update this yearly, and there are also plans to possibly be able to pull in extra facility information from outside sources that may not have the level of attribute population, basically, like being able to like have this 100% or very high percentage of the database that we populated, and really just kind of get a bigger scope of the amount of solar that's actually built up in the United States here. So there are plans. I know there's a lot of questions that come in about like, hey, you missed this facility or this facility here. And we do want to make this as comprehensive as possible moving forward. So it's just this first version of it, we really wanted to focus on having just a very clean attribute table, being able to provide the best data possible for everyone involved. So, and I think that's it for me. I think it's back to Sydney, maybe.
Yes, thank you. So I know Zach just went through a lot of information fairly quickly, but we do want to point you to our resources where you can kind of go through all this at your own pace. First thing I want to point out is the link to our code book that describes all of these attributes in detail. There is also a paper that we've released that goes in great detail into our data sources and the process of putting the data set together. So we invite you to follow the link there and to check out the paper. And this here is an image of the code book that's available to help with analysis of the data. And then I'm going to pass this off to Chris, who's going to give a demo of the website and the viewer.
Thanks, Sydney. Let me know when you can see my screen. I'll share now. Good. Okay, great. Thanks, Sydney. As Ben mentioned, my name is Chris Garrity. I was kind of tasked with building the web application to serve some of this data, build the web space in general, and build some of the data offerings that we allow for public to download. So I won't go through the web space completely, but I do want to highlight our Get Data area. This is where we have our data and web services. One of the most important parts, I think, about these national scale databases is that we want to get this stuff out to as many folks as possible. We have a wide range of users, all with unique needs. We have folks that just want to kind of look at the data in their area. We allow that to happen to the viewer, which I'll demo here in a second. But we also have folks that want to download kind of the geospatial data. So we provide that information in kind of legacy formats like shapefile and GeoJSON, and obviously tabular data offerings we provide in CSV. We also provide these as web services. The advantage of web services is that once you connect to these services, you're kind of in sync. So as we update the database on our end, you don't have to worry about kind of coming back and seeing if there's any updates. You're always in sync with kind of the latest version. So we offer a couple standard geospatial kind of data services, one being a cache data service, which is essentially a snapshot of the data. It's very snappy because it's cached, but you're limited in your kind of dynamic capabilities with it. So you're not doing dynamic filtering or dynamic styling with that service. You're just kind of looking at the attributes and kind of looking at, like I said, a snapshot of the service. And for folks that want a little bit more dynamic aspect to the service, we offer the dynamic version of that. So again, all this at our data and web services page, but more and more we're finding that folks are consuming these data streams as APIs. APIs have an advantage of that I can connect to my API simply by hitting this resource endpoint, which is simply a URL. And any software that can parse our data response, which is in JSON. You can see one of our sites right here. Can leverage this API. And much like the geospatial services, once you connect to this service, you're always in sync as we make changes to the database. One of the great things about these APIs is that you really can connect to APIs almost in every kind of software package at this point. I can use this to leverage this data in a Jupyter notebook. I can leverage this data in geospatial software. I can leverage this data in Excel just by connecting to a URL. One of the really awesome things about APIs in general, they've been around for a long time at this point, but is you can customize the way that you get your data. So if I just cared about, for example, getting the solar information in Nevada, I can just append a simple query to my resource endpoint that I showed you at the beginning, and I'd have a customized data stream with those sites that are just in that state. So we really done a lot of work to kind of show folks how you can access this data, how you can customize it, and walk people through kind of connecting to our API, because we're seeing more and more people accessing our data through these type of streams. We modeled this web space in our deliverables based on a highly visible product we put out called the wind turbine database. And by far, what we saw was, 95% of the people that interacted with the data did it through our viewer, right? So the idea, here's the viewer. Here, the idea is that you don't need any of this specialized software. You don't have to worry about data or downloading raw data formats. You can just kind of interact and visualize the data in a web browser, right? By far the most popular piece. So when you launch the viewer, you see the kind of the distribution of kind of the arrays at a national scale. So we, by default, we're here at the lower 48, but there is data over here in Hawaii. It gives you kind of a good idea of the distribution at that scale. Notice up here in the right, you see that we're currently showing 3676 projects with a total rated capacity of about 55,000 megawatts, right? So as I pan and zoom to the area, you'll notice that those metrics will change based on kind of what I'm looking at. And even at the national level, since we're using what are called vector tiles as our technology, these are very fast. So I can apply a range of filters to tens of thousands, hundreds of thousands of features through this technology. So for example, we allow folks to kind of filter by type. So greenfield projects versus non. We allow people to filter by capacity. So in this case, our kind of cooler colors are the lower capacity facilities. Our hotter colors are the higher capacity facilities. So I could, if I wanted to, let's say, look at capacity, sites with capacities that range between 12 and 22 megawatts, you can see that as I change my range filters, my viewer dynamically updates to reflect those changes, right? And we do that for years as well. But in general, most people will be in a more regional view. So if, let's say, I wanted to look at sites in Sacramento, I'm going to zoom to Sacramento, and now I have a more regional view. What happens when you get kind of in a regional view, you notice that we have now a record table that is populated on the right-hand side. And obviously those are the facility information. So for the records table, we provide information like the name, the year it went online, the access and site types, and the overall kind of footprint, the area of that information, of that site. I can sort by these by some specific attributes. So for example, if I wanted to know the largest footprint of a facility in this area, I could kind of sort by area. Or if I wanted to know the highest capacity facility, I could do the same thing on capacity. So in this case, Mackenzie site is the highest capacity facility in this area at 30 megawatts. Down at the site level, as I get closer to the facility, we can start seeing the panels in the satellite base, right? And when we click on the facility, we can get information, a little bit more information about what we have in the attribute table. So as Zach mentioned, we have things like project name, we have rated capacity and AC and DC and acreage and area by square meter. One of the most important pieces is when we capture that data, there'll be areas where you will see a polygon, but you won't necessarily see an array, and that's because the underlying base map imagery is older than when it was captured. So knowing that timestamp for when the facility was digitized is quite important. And then we have all the other things that Zach had mentioned right there. So we also wanted to provide folks kind of some different ways to kind of look at the data as well. So we have not only the kind of records table view there, we have an idea that we wanted to build some visualizations that were dynamic to my area of interest, or whatever was on screen that we could would dynamically change as we applied filters and or panned to our area of interest. So in this case, you can see that we have a histogram up here of distribution of project capacities. So in this case, as I mouse over the bars of that histogram, I see that there are 26 solar projects that are between 10 and 5 megawatts. And in this case, there's 2 between 5 and 10. So again, it gives you a quick idea in your area of kind of the overall distribution of project capacities there. We have also, we leverage some of the attributes that Zach mentioned and dynamically give people an idea of, in this case, access types. So there's 12 fixed sites there. As I hover over these components, that is updated in the viewer. You can see the highlights change. So there's 30 single access sites. And we realize that the general public doesn't necessarily know what a single access site means. So we do provide information to folks who are new to the database what these things mean. And we have, as Zach mentioned, his confidence scale. So in this case, we have 46 high confidence sites and 3 low confidence sites. And we spell that out. We also allow people to kind of get an idea of the cumulative capacity over time in these areas. So in this case, in 2007, there was 1 megawatt of cumulative solar project capacity. And by 2019, again, there was 122 megawatts in this area. So again, just getting people some information without having to dig into the data or parse queries in a spreadsheet. All these things work together. So if I, let's say, wanted to get just this information for Nevada, I could add that keyword Nevada in my keyword search, and again, all these components are tailored to that. So I can even combine that with, let's say, I'd wanted sites in Nevada between 2016 and 2023. So again, all these things work together to get people information based on some queries that we thought would be quite useful. So there's a lot more you can do in the site. I will mention that we have a pretty exhaustive help page where we walk you through the components. We have animated graphics to allow people to kind of see some of the workflows that we envision and walk people through those pieces. So that's it in a nutshell. This is version 1. We have new functionality in beta. We are exploring segmentation, machine learning pipelines for data capture. We're exploring some of the large language model technologies to kind of train on this database to maybe implement some more contemporary functionality. But we're really happy that this is out, and we're getting a lot of good feedback. With that, I will stop sharing and pass it back to Sydney, I guess.
Yeah, Sydney, if you'll go back to yeah, that's a great slide. You're in presenter mode currently. So that, thanks everybody. What a great presentation. And a lot of information was shared today, though undoubtedly we haven't answered everybody's questions. There are lots of questions. I'm going to be the MC for a time being here to answer those questions. Do search out the Q&A button on the Zoom viewer and ask those questions. If we don't get to them today, we will answer them after this webinar is completed at the top of the hour. But we'll do our best to answer some. So I'm going to feed folks some questions now. Chris, you mentioned this during your presentation, but I thought it would be worth highlighting. We had a question come in saying, oh, I can see a polygon, but I can't see the image of the panels below it, and asked, how often are you updating that imagery? So maybe you could explain a little bit more about how we get that imagery and why sometimes that happens.
Sure. So the base map imagery is provided by a vendor. In this case, the development environment that I was using, the libraries I was using for that application is by a company called Mapbox. So we're kind of, we can't control when they kind of update their underlying imagery, right? There are ways around that. We have discussed essentially passing newer image chips at every kind of solar facility. So you'll always kind of get, you'll always see an array essentially underneath those polygons. But right now for version 1, we're just kind of relying on whatever we can get from their base map service. But it's definitely top of mind for ways around that.
Great, thanks. Sydney, this is maybe for you, and of course Zach can chime in as well. There are a number of questions here about, why didn't we include large rooftop facilities? What about facilities that aren't showing up in EIA right now? What do we do about that? Maybe you could just quickly outline the rules we had initially for this data collection effort, and maybe what we're thinking about in the future.
Sure, yeah, I can start that, and Zach can chime in if I miss anything. So in terms of rooftop, our primary answer is that the scope of the project that this work was completed under was focused on ground mounted. So it was not sort of within our present scope of work to include those facilities. However, as future versions come out, that's something that could potentially change. But for the moment, we're kind of tied to the set of larger ground-mounted facilities. And as Zach mentioned, we stuck with the EIA Form 860 data as sort of our foundation in this round, because we wanted to make sure that we could include a lot of attributes with all of these facilities, so that kind of a complete analysis could be performed of each one. In this instance, we didn't want to just sort of provide a polygon without being able to say what it belonged to, what type of facility it was, and having a way to point people to kind of its generation data and other useful attributes. Yeah, Zach, I don't know, is there anything you want to add?
I mean, not really. I thought you did. I thought that was good. Rooftops. Rooftops tricky. We've talked about how you even digitize rooftop. If we're more concerned with the actual full rooftop, or if we actually do the tight to panel arrays on top of rooftops. So there's a lot of questions with rooftops. We do understand it's an important piece of solar generation, and in the future we thought we think it would be really cool to add that in. We just need to see if it's possible for us at this point. So thanks.
I guess one more thing to note about rooftop is the AIA Form 860 data. They are available for a number of the larger rooftop facilities. So the data is there, a point location is there. It's just that we don't have the polygon for it at the present time.
Yeah, and this question was asked during the webinar, and I answered it. So, what portion did you not include that were rooftop facilities? It's 1.5 or 1,500 megawatts compared to around 86,000 megawatts that we started with. So it constitutes about 1.5% of the data set. So yeah, we're missing some, but we're missing a relatively small percentage of that. All of that information about the percentages that are not included are in the paper. I just, again, posted that link into chat. So please go ahead and get that. It's free to download, and you can read all the gory details about how these data were put together. A lot of questions are coming in about updates. When's it going to happen? Can you guarantee when it's going to happen? We really want more data now. Please. So I don't know, Zach, Jay, Sydney, would you want to take a shot at that? Predict the future?
We are starting on the work to include the facilities that came online in 2022 and 2023. I don't know if we can make any exact promises about updates. We hope that this will become sort of a permanent product that we can provide. We do plan to update at least this next year. Some of it depends on our support. We would like to update at least annually, possibly twice a year. In some ways, at least at the moment, we are tied to the releases of the EIA 860 data, as that's our primary source we're working from. If we develop relationships with other people with more data, perhaps that could change the timelines, but we expected that kind of a second version could be completed much more quickly than this first version. As this time around, we were trying to capture everything, from 2021 all the way back. And this new round would just be facilities that came online in 2022, 2023, and that we have imagery for. So it should be a smaller lift. And I would hope that, by the spring, we could have something, but please don't quote me on any hard dates, because this is still kind of a learning process as we see how this all works and what everybody takes away from it all and what's needed.
And just to say, as we make updates using the new 2022 and 2023 data, we will be going back and looking at facilities that are already included in the database that we may have low confidence in due to imagery, due to attributes, things like that. Any kind of information that comes in from those email addresses that are posted there, the USPVDB team, like anything that comes in there, we store all of that data and we plan on using it. If people are giving us information on facilities, on things we missed, on some of the disentangling type of facilities, if somebody's very familiar with a certain facility and they know that this panel belongs to this facility, those are things we're going to take into account and kind of update with future releases to make the database, better than it already is. So.
Great. I'm going to ask a question and answer it quickly here, just picking up on what Zach just said, which is, we've found with the U.S. wind turbine database that the user community is essential for us to have great data out there. We don't know everything about these data, neither do EIA. We do our best to learn and make sure our information is accurate, but we are always making mistakes or just don't know how to do it correctly. And we encourage this group of users and to be in touch with us. We have emails there on this page, and I also just pasted them in to the chat. You can directly add comments about a particular project from the website, and so that's one way. You could just email this group. We're going to get those emails there. And, if you have great information about projects that aren't shown or shown incorrectly or whatever, tell us. We'll get the updates made and have a better product for everybody to look at in the future. Okay, so the other question, I'm going to go to Chris on this.
Ben, I just wanted to follow up quick.
Yeah, Jay. Yep.
Regarding the users, we also recognize, we just talked about updates, and I'm sorry we don't have a firm sort of schedule like here will be the updates. We know that there are users who on the wind side have integrated our data into their workflows and want a regular schedule. We're working on that. And we'd like to do the same with the solar. It's a matter of getting it off the ground first and then getting the logistics ironed out in terms of funding and workers and workflow. And we're working on that. And hopefully we'll have a sort of set schedule that will help everybody in the long term. So.
Yeah, actually, and I should just also note that we have funding for the next 3 years to update these data. So they will be updated. We're just not exactly sure how long it's going to take us, given our capacity. So want to be clear about that. For 3 years, these products will be updated for sure, and hopefully beyond that as well. So going back to Chris on this one, this is a question about querying. And I don't know whether you want to share your screen briefly or not. It asks, can users query to locate all of the projects of a certain type within a state? For example, all the brownfield projects in New York.
We can certainly query by states. You see all projects by state. We don't have a filter by brownfield, for example. But I mean, these are the type of things that we could add in almost real time. You know, these type of suggestions are things. This is what version 1 is for. So we get calls all the time, like, could we add this, and we can. So to answer your question, yes, you can filter by state, and you can get into some of those things. But I don't believe that we can do that on brownfield at the time. But something we can add to our list of suggestions for sure.
So maybe just touch on the API ability to do that, and also the CSV ability with a download. Or
sure. I mean, you know, with the API, you can essentially query by any attribute that is in the schema, right? So you can 100% do that with the API. You would just add the parameter, you know, by state equal to and type equal to. So that is a resounding yes, right? And you know, with the CSV, you could just do the same kind of things with whatever software you're using through traditional filtering, right? So yes, certainly can do that in the tabular side and the API side.
So there are a number of questions here about all kinds of additional data that folks would love to have in the data set, you know, capacity factors, the output of a project, the historical time series data of a project's development cycle. There was some, irradiance data, and Justice 40 data to understand how these projects are being installed in those very important categories of communities. I'll just throw it out to the group. You know, why is it we don't have all these data? I'll make it maybe easy. Why don't we have all these data included in the viewer?
Well,
where do we stop is the hardest question.
Exactly.
I mean, there are hundreds and hundreds of geospatial data layers that people have interest in intersecting with our energy infrastructure data, be it either the wind turbines or the solar. And at some point, you can't put them all in there, right? And so we have so far been approaching this as sort of a minimalist perspective, like we're going to put the energy infrastructure information in there, and other types of geospatial data or other things that you like to intersect that with, that's more or less your responsibility to do. That said, I mean, there are I don't know, it's tough. We vacillate on this all the time. It's just I'll leave it at that and see if anybody else wants to follow up.
Yeah, there's certainly a balance between, you know, our power users and kind of the general public that just wants to kind of see some stuff, right? And you know, the success of our viewers have been that, you know, anybody can kind of look at it, and that's where we're getting a tremendous amount of traffic. And for folks that really want to get into it, they're usually accessing the data themselves, or integrating again the API or the data services into their own applications and or modeling software or notebooks or whatever they're using. So it's that balance, you know.
Well,
Yeah,
great.
I think we want to highlight that, you know, we provide a CSV file and a shape file, that, you know, if there is a particular geospatial layer that you're interested in intersecting with these facilities, we absolutely want you to do that.
Why don't we end it there? Thanks to everyone that attended. We had a great number of participants, and thanks for the presenters and the full team. This was such a fun project, and we look forward to continuing to work together and interact with you users on these data over the next bunch of years. I realize we haven't answered every question. We will try to get them answered via email after the presentation. And again, this recording and the webinar slides and the paper will be available, and we'll send them out to everybody that attended and anybody that registered. So with that, we'll end the day. Thanks so much. Take care, everyone.